So hi everyone, good afternoon. I know we're kind of early, like 15, 20 minutes early. But yeah, here we go. I guess we have more time for questions later. So we are almost done with 2 days of awesome talks about a lot of things, Android and also Android things. So before we begin, let's do a short exercise. So I'm gonna ask questions, and if you answer yes to the question, stand up. Okay? Stay standing up as long as you answer yes. But if you answer no to the next question, you can sit down. Sounds good? Yeah. Alright. Hugo said do it, so let's do it. So, first question, who has a prod app or an app that's currently released in Google Play? Okay, so among those standing, with the prod app, who has a crash tracking tool shipping with their app? Like Crashlytics or Hockey app or, you know? Okay. Okay. Is that good? So, those who with a prod app who has a crash tracking tool, who of you look at the reports? Okay, alright. So I lost a few people there. So, so those of you with a prod app who has a crash tracking tool and you look at the reports, how many of you have ever been puzzled or confused by like, how did this person even get here? Or how did they get this crash or something? Like if you've been confused at all, or if you question their decisions as a user. No? Okay. So, if you understand all those crashes, like, have you ever been puzzled though by like when you try to debug it, like you can't replicate it? No, you can always replicate your users' crashes? Oh, you're really good developers. Okay, so, alright, you can now all sit down. So, if you were standing up, then I hope that you learned a thing or two today about like how we do Android development. You can all take your seats. So, for those of you who said no to any of those questions, please put in error tracking and crash tracking. And once you do, please look at them. Like, don't put it there just for like, you know, just for the sake of putting it there. Okay, so let's do this. So hi, I'm Zarah. I'm an Android developer for domain.com.au. I'm based in Sydney, and today I will be talking about debugging and code improvement tools that can help you in your day-to-day Android development. So we will go through tools that you can enable via code, those tools built into Android Studio, and a few third-party libraries. So, first, a reminder. So when doing these kinds of things, right? When you're trying to set up your machine for debugging success, you need to remember that first is knowledge. Read about what's out there. Chances are somebody already tried to do this thing you wanted to do, and maybe they wrote or spoke about it somewhere. And the second point is there is no quote-unquote correct setup. So once you read about those tools, someone's setup may not work for you, but it may work for them. So try to learn about what those tools do and apply what works best for your workflow. So yeah, that being said, I'm here to let you know of some of these tips and these tools, and I hope that I can help you explore how you can make use of them. Alright, so first we do those things you can enable in code. So, Jeff is an Android developer I've known for quite a while now. So, fragments, right? It's the thing that's like a little tricky topic in Android ever since. Most people hate it. So, what do you do if like you're in the point where you have to debug fragments and you're like about to go into those dark depths of despair? So you can enable debug logging in Android Studio. So what this does is it shows you a lot of information about the fragments. So basically, lifecycle state transitions, bundle values, instance IDs. This is from G-Square. It's kind of low res, but yeah, so this is from G-Square. So it shows a lot of information about what's going on with the fragments. So I think it's most useful if you want to look at life cycle state transitions, because that way you don't have to override your on resume or create, and you timber or you log like the fragment is now created or the fragment is now resumed. So if you just enable that one line, everything will be displayed for you in Logcat. So, but what about services? Services, we usually have them long running in the background, right? Like sync services, like for domain, we use it to sync your shortlists or your saved searches. So how do we debug them? So one way is to ask the OS that you want to debug your service. So this is the relevant line. So Android.os.debug, wait for debugger. So what you need to do is you need to put it usually in the onCreate of your service, and then you put a breakpoint after that call to enable debugger, and then you run your service. So this is an optional step of changing your run configuration to tell Android Studio that you don't want to do anything, like just build my app and then install it, but don't do anything. So, and then you trigger the service. How do you do that? It's kind of convoluted. You go to settings, look for the app you want to test, and then click on the overflow menu and then sync now. So now what it does, it will trigger your service, but it will freeze the thread until you actually attach the debugger to the thread. So if you go to Studio, you look for the same process name that you declared in your manifest, and then you attach your debugger. So one thing to make sure is to remove this call before you ship your app. So like to be safe, you can wrap it in a if build config is debug. So, but we know that Android Studio has a lot of built-in tools as well. And the tools team has been hard at work over, like the past year, building a lot of tools and rebuilding what's already in Studio. So, is anyone still on Eclipse? No? Okay. Like the last time I gave this talk, there's one person, so. I hope everyone's on Studio now. We're at like 2.4 already. So let's go through some of the tools that's available in Android Studio. So we're going to spend a bit of time talking about the debugger and what happens in Studio and what it shows you while you are debugging. So the debugger. Usually when we want to debug something, right, our first instinct is to launch our app in debug mode, which is the second one, the small bug with the play button. So, however, for a non-trivial app like mine is, it can take like quite a long time. It can take forever. So, what do? We should say no to the green bug. Don't click on the green bug. So, the alternative is you can run your app in normal mode. So, you do that by pressing Ctrl-R, or you click the play button. And then you attach the debugger after your app launches. So to attach the debugger, you click on the fourth button, the small device with the small bug in the corner. So there is no built-in shortcut for it. But what we can do is we can create a shortcut. So how do we create a shortcut in Android Studio? You go to Preferences, Scheme Map, yeah. But nobody's got time for that, right? So what do? The easier way is to do Command-Shift-A, which brings you this universal search for actions in IntelliJ in general. So, and in Android Studio. So you type in keymap, search, and then you search for attach, and then it gives you this dialog box. And then you can try as many times as you need to until you get to a shortcut that doesn't clash with anything currently. So, yeah, once you've defined that, you can do Ctrl-R to attach, to run the app, and then your new shortcut to attach the debugger to the process. So, easy peasy. So, what are breakpoints? Breakpoints are those red dots in the left gutter in Studio beside the line numbers. Yeah. So you click on the gutter to put a breakpoint on the side to tell Studio that when you get to this part of my code, please stop because I want to do something. So, and aside here, I have enabled, inline parameter names for literal call arguments. So this means that whenever we call a method that has input parameters in it, Studio will display the values that you pass into it and what the parameter name is. So if you want to enable it, you go to Preferences, Editor, Code, Folding, General Code Folding, and you check that little box. Okay, end of aside. So how do we make the most out of breakpoints? For one, we can tell Studio that we only want to hit those breakpoints for specific conditions. So say we can tell it to, well, don't actually stop, but just log something for me, or stop when you hit a certain condition, not every time. Or you can tell it to stop just that one time and then like ignore the breakpoint as if you disabled it. So there are a lot more options available if you right click on the breakpoint and then you go to Command Shift F8. So aside from stopping at specific breakpoints, you can also actually tell Studio to suspend in like quote-unquote random exceptions. So if you press Command Shift F8, it will, sorry, it's kind of blurry, huh? So if you press Command Shift F8, it will open the breakpoints dialog, and then you can add a Java exception breakpoint. So say you are debugging a null pointer exception somewhere. So if you can't find the code where it happens, you can make a breakpoint for null pointer exception. So I'm actually typing that, I promise. I was adding a null pointer exception. So once you add it, you don't even have to put a breakpoint anywhere. But if you debug your app, the Android Studio will stop at the exact line that will throw the null pointer exception. So instead of like crashing outright, it will stop there and then you can like look at what's going on. So I think it's pretty cool and pretty useful, especially if you have like no idea where the crash is coming from. So it's worth it to note that it will also stop even if the crash is in a library, or in generated code. So if you are debugging a particular issue, I find that grouping breakpoints is really helpful for me. So this means that if you are debugging like a list or like something difficult, right? And you tend to put a lot of breakpoints, and then like once you figure it out, it's either you go through the file and remove each of those breakpoints one by one, but if you group your breakpoints together, you can enable or disable all those breakpoints as one. So remember the things I said, like you can do with a breakpoint, like you can stop at a particular iteration, like all those things. It also applies to a group. So it's basically like managing a group of breakpoints. So yeah, if you're done with an issue, just disable that group and you're done. And then if the issue arises again, you can just re-enable the group and then you're back again. So the debug tool window. So when the debugger is attached, I usually go to the debug tool window. It provides a lot of information. You can open it by pressing Command 5, I think is the default. So as I said, this shows you a lot of information. My default setup is like this. It has 3 frames, 3 panels. The frames, variables, and the watches panels. So I can tell you a bit about what each one does. So the first window is the frame. So it's the one on the lower left. Your right. My right, your left, my right. So that's one. So the one in the corner right there. So the frames window shows you all the calls that were done until you hit that particular breakpoint. So each line of code and each method call, basically, that was done, it's all listed there. And if you click on each particular line, it will open the file directly on that line. So the second pane shows you all the variables that's available in the current frame. So it shows you, like, you can expand it and then you can look at all the properties available, if it's a view, if it's a variable, or this, which is an instance of a fragment. So it has all the variables in their current values. So another way to inspect a variable instead of going through this pane is to inspect them inline. So I usually do this rather than doing it on the pane because it gives me more context on what I was doing with the variable. So especially if I'm doing like a lot of math, this is particularly helpful for me. So how do you do this? You right-click on a variable and then you click the plus. There will be a plus like all the way to the end of the pop-up. And if you expand it, it will give you basically the same thing as in the variables view. So if the variable you are inspecting is used in an expression or like in a computation or something, you can evaluate that by highlighting the whole expression, and then you choose, and then you right click and then you choose evaluate expression. So in this case, I think it was doing computation on a height of a view. So, you know how views can have dynamic height, like at runtime, you don't know how big they are. So if you're doing computations on that, you can highlight the whole thing, the view that get height divided by whatever, and then choose evaluate expressions. And it will show you what the result will be as if that whole expression was run. So, most of the time, however, we are not interested in computing values on the fly as we debug, right? So we know what variable we're interested in. We know if we are doing any like weird stuff to that value. So this is when watches become extremely useful. So watches is the last pane in the window. So what actually are watches? So watches, in the watches pane, you can add any number of variables and expressions. I don't know how many the maximum is, but like you can add a lot. So, and the watches pane will resolve them all for you in the context of the current frame. So what does this actually mean? We have this sample here. So it means instead of pausing and then highlighting and then clicking evaluate expression, you can just add them to the pane, and Studio will update the value for you as you step through the code. So watches can also be added manually. So if you go to the watches pane, there's a small plus button right there, and then you can type whatever. So the good thing about this is it has autocomplete too. So see how getting the view and then the get child at something. So you don't have to memorize the syntax. Watches can autocomplete for you. So the thing I like about watches is that once you are stepping through the code, these watches are retained across debugging sessions. So even if you close Studio or you stop debugging or whatever, like these watches will stay there. Like it can, you need to do a bit of housekeeping though, because like it can grow to like a huge list. So once you, I'm showing here like once you step through the code, so you press F8 to step through the code. So once you press, every time you press F8, the watches pane will update dynamically with the values as it resolves stuff along those steps. So it's kind of useful. So what does this mean? How can this exactly help us? So it means that you don't need to toast or log or timber or whatever your values. So especially if you're doing like view property manipulations, you don't need to height is now blah or like margin is now blah. So you can just add watches and you can see what values are, or what the underlying values are. So it's like evaluated expressions that I mentioned earlier, but like lots and lots and lots and lots of them. And they're persistent across sessions, so you don't need to re-add them. So if you're looking at particularly nasty bugs, it's really helpful that they always stay there. So it's also a quick and easy way of changing expressions on the fly. So you don't necessarily have to do the math you are doing, but like if you're thinking like, what if I change the device or to something else? Like, will it result into something else? Like, you can do it via watches. So there's like a lot more features about watches and breakpoints. You can reference the IntelliJ blog. So, yeah. So once you have fixed your bugs, the next bit you might want to do is focus on optimizing your app, or like maybe just figuring out like what's going on inside it. So there is a star, and the very fine text says very shallow. So it's a very shallow dive into APK analysis. So the first thing that like when I'm working on an app, the easiest I think, or the most straightforward way probably to optimize it is to flatten your view hierarchy, right? So how do you start looking into what you can optimize into your view hierarchy? You use Layout Inspector. So it's that button right there. You click in Android Monitor. You can also access it by going to Tools, and then Android, and then Layout Inspector. So what does it give us? It gives us this blurry screen. Well, it's not blurry in Studio, blurry here. So it's basically a screenshot of your view hierarchy at the time you click that button. And it's interactive because like you can click on anything on the screen and all the properties of that view widget will be displayed on the right. So it shows your view hierarchy also. This is from Plaid, Nick Butcher's design library implementation sample app. So the next thing we're going to talk about is system information. So it's basically an info dump of anything you can think of at a particular point in time. Like it's literally anything. So it's accessible from Android Studio, like the third button right there, in Android Monitor. You can get to it by pressing Command 6. You can open Android Monitor by pressing Command 6. Okay, so what does it give us? So see the screenshot? It gives us like 1, 2, 3, 4, 5 different options. So I'm gonna describe each of those options really, really quickly. So Activity Manager State, the first one. It shows your activity, lifecycle state, your config values, if you have MCC, MNC, what the language of the device is, display metrics, orientation, fragments, fragment manager states. It's like, it's a lot of stuff. I have a sample here, but you probably can't see it, so we're just gonna skip it. So, package info, this is anything about your manifest, basically. So, if you handle deep links, all the deep links you handle are listed there. If you have content providers, they're all listed there. Permissions, what has been granted, what you have asked for, what the user has denied, and what you want to ask for but haven't asked for yet. So if you're migrating to M permissions, which I guess everyone should have by now, you'll see the list of all permissions in this file. So it also has info about installs. Like, when did this device first install your app? When did they last update? Lots of APK info, like if you have ABI splits, what screen support, what screen sizes you support, all that kinds of stuff. Okay, so memory usage. So it's app summary broken down by who uses it. So the whole memory consumption of your app broken down by package and by view type. Well, not necessarily type, but like any object type, like views, activities, parcels, all those kinds of things. It also shows you your databases and how much memory they use up, and asset allocations if you have font files bundled in your app. Let's see if we could. So yeah, it's like this table that has all the memory information that's being used by your app. So the next one is memory usage over time. So this one is particularly useful if you find that your app is eating up a lot of memory over time. So you just like leave your app running, like interact with it, and then run this dump, because it will show you aggregation of all this information over the last 24 hours, over the last 3 hours. So it's an overall summary of your app statistics broken down per package. So there's really some like low-level information in this dump. If you're into that kind of thing, I don't understand it. So like see, you have like kernel information, cache memory, it's like really low-level, like very, very low-level optimizations. So the graphic state can tell you how well your animations are doing. So in particular, if you're, this was particularly useful for me when we were migrating our list views to recycler views, because it shows you like how efficient you are doing your animations. So remember that this is a dump at a particular time, right? So if, for instance, you open your app and you do a graphic state dump, it may show that you're doing very well, like you're not dropping any frames. But once you fling through a recycler view, because like Android will try to optimize and not like draw everything on your screen, right? So chances are you're gonna drop frames. So this graphic state dump will show that. Alright, so once you get to that point where your app is mature or maybe big enough, you may need to start caring about applying ProGuard rules. So now this is a beast all by itself, right? And like I started learning about ProGuard and it's like it's all very confusing. And it's like I really don't understand what some of the rules are doing. So like when especially for me when I'm learning to try something, usually it's just like go all over the internet and copy paste stuff into my app, right? It's like I don't even know that it works. So anyway, so the first thing I learned to look at when I was trying to understand what's actually going on is to look at the files generated when you do assemble release. So if you have Minify enabled, Android Studio will generate files for you after you do your build, well, after it finishes the build. So the first one that's really useful for me is usage.txt. So all these files will be in your module name /build/outputs/mapping/release. So I'm gonna put up the link. But this usage.txt, it will list all the methods and classes, well, basically anything that ProGuard removed. So if you want to try and understand like what happens when you change your --keep configurations, or if you decide to keep more files, you can compare various versions of this usage.txt. So the other file it generates is mapping. So it's also in the same folder, in the build outputs folder. You will need to keep this file if you obfuscate your code. So because it's a mapping of the obfuscated code with the original names. So if you are doing maps and you see crashes from maps, like it's virtually impossible to debug it, right? Because it's all just aaa.bbb. It's like, what the hell? So for your own app though, if you obfuscate it, you would need to keep a version of this mapping.txt. And by keep, I mean like copy it from where Studio created it to another folder, because once you do another assemble release, like it will just overwrite it. So you can upload this file to the Google Play Dev Console, and if user support crashes there, or if you see crashes there, it will automatically deobfuscate the code for you. So if you want to do the obfuscation yourself, there is a script in build tools/ProGuard. It's called retrace, or ETRAC, retrace. And you can run it and give it the file path to your mappings.txt and the stack trace, and it will make the stack trace readable again. So there are two more files that it generates, seeds.txt and dump.txt. I've not done any of this yet, but essentially dump.txt will list the internal structure of the class files in your APK. But like, remember these are all text files, so it's just lines and lines of package and class names and field names and everything. So like I'm more visual, so the thing that helps me more is the analyze the APK function in Android Studio. So once you see those lists, right, like if you want to visualize, like, but actually how big are my remaining files, or like how many methods do I actually have? So I know that there are a lot of third-party tools that developers came up to like analyze your APK, but this one actually slipped my radar. Like I didn't know it was available really. So how do you analyze your APK within Android Studio? You can drag an APK from the Finder to Android Studio. So if you tried dragging and dropping an APK into Android Studio, it will automatically run the tool for you. It will show you this result. So you can also do that by double-clicking an APK from Studio, or you can go to Build, Tools, Build, Analyze APK. Yeah, Build, Analyze APK. So this Analyze APK tool will show you what resources are being used, what your merged manifest will, what your final manifest will look like. It will also allow you to compare two APKs. So if you are like, if in debug you are not running ProGuard, but in production you can compare those two APKs, and it's like you can see the size difference and the method count difference. All those kinds of things. So it's really useful because it will show you by package which one has the most classes, or which one has the most methods, which is Android and support library. So Google announced maybe a month and a half ago, that they're gonna open Instant Apps SDK soon, right? So the size limit is 4 MB. So good luck to all of us. This tool will be useful. So there is a really new version of Android Studio in the Canary channel. They announced it maybe a couple of days ago. So they have this new profiling tool which will replace Android Monitor. So maybe what they talked about today will be obsolete when this comes out, but yeah, so it looks really nice. If you are not in the Canary channel, you might want to like download it and check it out. It looks really pretty. So what about third-party tools? The first one I want to talk about is Yugo. Yugo is an annotation-based library. It's made by Jake Wharton. And it's super easy to add in code. So this is what it does. If you annotate a method with @debuglog, it will log stuff about your method call in Logcat. So it shows you if you have input parameters, it shows you what those input parameters are, what the result of the method will be if you return something, and how fast or how slow that method executed. So I highlighted the relevant values there. So it's worthwhile to note that there's a built-in tool in Studio, but you have to call it yourself. It's not an annotation. So if you type logm, there is a live template that will give you something similar, but not quite. But it will automatically generate a log.d line for you. So it essentially has everything except method execution time. So the ADT plugin, who has heard of the ADT plugin? Right, most of you haven't, so I highly recommend you check it out. It brings you easy access to actions from within Studio. So what are those actions? You can uninstall the app, kill the app, restart the app, clear your caches, all those kinds of things from within Studio. So usually to uninstall, like you get your device or your emulator, you uninstall the app yourself, right? But if you have the ADT plugin, you can just you can trigger the plugin, or bring up the plugin pop-up, and you can just select available actions. So you press Control-Shift-A to generate the specific plugin information, or you can do Command-Shift-A and search for ADB something. So yeah, get it from that GitHub link. What about Stetho? Stetho is this massive tool from Facebook. They open sourced it maybe early 2015. It integrates with Chrome developer tools, which means you get this baked-in nice UI from Chrome. But like they say that they have a lot of features, but what can you visualize exactly using Stetho? So you can modify your DB. So instead of having a third-party SQL browser, SQLite browser, you can just do it from Stetho, or your shared preferences even. You can do network inspection. So usually it essentially brings together a bunch of tools that we do separately. So instead of using Charles to do network inspection or Postman or something, you can just use Stetho too. It shows you your view hierarchy, and it comes with dump app. Dump app is a command line tooling, so you can write your own Python scripts, and it essentially means you can modify your maybe shared preferences or something from the command line. So they ship with a couple of sample scripts, so you can check out their GitHub repo. This is a sample screen grab from network inspection. So it shows you like what the HTTP calls were and how long they took and like what the order they were called in. So because Stetho needs like some setting up if you want to include it, but if you're just concerned with looking at what the network calls you are doing are, I recommend using the curl interceptor by Jeff Gilfeld. So there's it's just a gist, it's not a repo. There's the gist for it. It logs HTTP requests as copyable curl commands. So essentially, all your headers, like everything you do when you do HTTP calls, it logs into Logcat, so you can just copy paste into the terminal or something. So if you are using HTTP 3 though, Square has their own HTTP logging interceptor. There's the link for that, kind of long. So, but you can get to it from their HTTP repo. So, BitCat. Can you guess who made it? Jake Horton made it. Who knows Jake? Who doesn't know Jake? Who doesn't know Jake? Okay. So, BitCat is essentially Logcat with less pain, and by less pain, I just mean it's more colorful. So, it's less pain because like you can easily see what log levels are. So instead of running ADB Logcat from the terminal, which just gives you a dump of everything, like scrolling by really fast, with BitCat, it's color-coded, so like errors can be read, so you can easily see like, oh, something went on up there, and like I should go back and inspect it. So another thing that I found really useful is Leak Canary. So Leak Canary is by PY, so it's by Square again. Who doesn't know Square? Everybody knows Square. So Square has open sourced a bunch of libraries and tools that most of us use, right? So Leak Canary essentially gives you a notification when you leak something, when you leak anything, basically. So it has a very good looking UI. So it looks very neat. It has M style permissions too. So it will show you the leaks, but you can actually save it to a file and email it to someone else in your team. And it keeps tracks of all the leaks it encounters in one screen. So you don't actually have to, like if you don't want to create separate issues for it, you can just look at the Leak Canary app and see what the leaks you have to fix are. So you can mark a leak as fixed there. It won't essentially fix the leak for you. You have to do that, but you can mark a leak as fixed. So you can email the leak information to yourself. It's a huge, huge file. It's essentially like the Android bug report file that you get from your device. It's a pretty big file. But what if you really don't want to do any of these things? Like you don't want to integrate to any of that. It's like so much work, right? So how can we prevent it? I think by having better code, we would hopefully have to do less debugging. So how do we start getting better code? For one, I advocate the use of support annotations. So support annotations, especially if you're writing an API or like a util class or whatever, it is really useful at enforcing rules that your clients have to follow. So these are like, if you are asking for an ID, for a resource ID, you can specifically say if this should be a string or this should be a drawable or an int or whatever. So instead of passing like a random int value, you enforce that this actually has to be an r.layout ID or whatever resource value it is you're expecting. So probably my favorite support annotation is @call_super. So especially if you're making like a custom view and you do some setup in your base implementation and you want children in the hierarchy to call super. So like how we do, if you do an activity, you have to call super on create, right, in the activity. So similarly, if you have a custom view or a custom class or something, you can annotate a method with @call_super to enforce children to call your super. So if you use the support library, which I assume most people do, you don't need to add it. You don't need to add anything to have support annotations. It's already there for you. So this is a sample of what I was saying about enforcing what kind of resource should be passed into a method, for example. So another suggestion is to listen to lint. So lint used to be really bad. And honestly, like I got fed up with it and I turned it off. But now that it's really good and they're spending a lot of time writing new lint rules, I suggest if you turn it off, like me before, turn it back on and actually listen to it. If you haven't yet, you can force your CI at least, that if you are making a prod build, the build should fail if there are lint errors. So, and remember to use app_compat methods. I think one of the things that developers miss most of the time is that we fail to test on old devices, right? Because sometimes you just test on your own device, so you forget that there are some things that are not available in really old devices, especially if you target more low-level SDKs. So these are some of the resources that I talked about today. There are links to the sample code and all the tools that I have talked about. And if you have any questions, I have some domain branded stuff that I can give away today. Come on, I don't want to bring it home. I have like a notebook, some shirts, and some pens. If you don't want to ask now, I'll be hanging around until the end of the day. So come find me and ask me anything and maybe I'll give you everything. Hey, thank you.